Okay, Sue, I think we're ready to go. Take it away. She wanted to drive. I'm wondering if you lost her.
No mic. That really doesn't help. Okay, folks, sorry about no mic. Note well. Please, it's a new one. Read it. Enjoy it. There are participants. If you're a participant, you're expected to behave in a professional manner with respect and courtesy to all. See the guidelines there. If you make an ITF contribution, or if you're just sitting in the room, you should read the information about IPR, rights to contributors, and how it goes to the ITF trust. Please read that. If you are interested in the standards process because you want to watch your document go through, please read RFC 2026. And all when you participate, ITF is routinely making the public written, the audio, the video, and the photograph records available for the ITF, so including your personal information. So please look at the ITF privacy statement. How many people have clicked the QR code by now? I hope a few. If you have any questions, see the working group chairs of the area directors. Now, I wish I could think of a fun way to do that. Maybe next time I'll try to do it in a chanting song. Um, Anybody that wants to hear me chant it next time, just let me know. Okay, so the ITF has lots of GitHub, and IDR started its own GitHub, and we're continually trying to get new ways to make sure you know status. I found as an author that there's nothing worse than not knowing where my document is. So the ITF has GitHub, and the IDR chairs are trying to switch over more to GitHub because you can log in, you can check when something changed. Perhaps you use it for your programming. So what do we have there now? We have the current status, and we're also keeping our notes on our action items. So please take a look there. We also recommend putting drafts into GitHub. If you notice the draft ITF IDR link bandwidth went into the GitHub, and it made some of the process a lot easier to work through. John, raise your hand, John, put 4271 bis in there, and he'll talk about that. Okay, so status is also on the wiki. The long-term goal is to feed the wiki from the IDR GitHub, but we're working on it. Right now on the IDR wiki, we have draft status, early allocation, BGP LS and BGP SR Shepherd reports, templates. So we're trying to figure out how to instrument it. If you've got any comments on the tools, this is just our ongoing work to make sure we try to make things quick and easy. AC's always telling me, give me short deltas so I know what's going on. So there is an ongoing charter discussion that's in there as well. So see the ITF working group, IDR working group charter. Caton has a suggested problem that he's not got enough seeing enough cycles on core BGP, and he has proposed solutions. So that's where you started. Talk to Caitlin if you're interested in that. It's an ongoing discussion before we send it to the mail list. We're
So, Caton has
Yeah.
raised his hand. Should we give him a moment before you
Oh,
proceed?
please! It's always good to give Caitlin a moment.
Okay, thank you. If you could go to the previous slide. So the context on this is we did the charter update or the proposed charter, and it was shared with the working group. There was one comment received from Robert saying that, hey, why are you not just doing core BGP work in IDR and move everything else to a different working group? Nobody else felt the same, or at least didn't speak up about it. That did get me thinking, though, as I looked at all the work that is evolving in the working group. There are cycles where different work areas bring a lot more work, and then some other things comes in and all of that. So the question really there, I would not necessarily call it a problem. I don't know. The working group should tell me whether it is a problem or not. The question is, we do see, or at least right now, if we go through this presentation and some more stuff probably coming out of the 4271 BIS, I have the sense that there is a lot more focus or work or topics related to core BGP, protocol machinery, operations on the internet, and all of that. The question is, and then there is all this other work that is listed there. The question is, are the folks working on or interested on one or the other topic? What are those sets? Is there a overlap? How much is the overlap? Is there a benefit of giving each set of folks their own focus to work on those topics, and how do we go about it? So that's the question. And as Sue mentioned, we welcome feedback. There may be different ways to go about this. And as Sue mentioned, this is under discussion. So any feedback on this will welcome, preferably on the mailing list, but yeah, anybody here as well.
And we tried to use this split for this ITF. So I'm going to dig a little bit further into the status. Thanks to John Scudder, we have 5 RFCs that popped out, and I believe CAR will pop out in a few days as well. So made a lot of progress here. Draft ITF, IDR, BGPL, SRVT, and MT is at the RFC editor in MESREF. So now we've got several things along the pipeline, and the revised ID that will free IDR, the draft ITF IDR link bandwidth, is about ready to go forward. The draft IDR, draft ITF IDR TS flow spec v6 policy needs to go with flow spec redirect. Now, I have a plea. I really need someone from Nokia or anyone else who's actually implemented the flow spec redirect 04 to give us an implementation report. The report we have in the document from Cisco doesn't really give me a substantial basis to indicate there's a second implementation. We either need an improvement, and a lot of documents are sitting behind this redirect as they use it. So there's use, but there's no one stepping up and telling me they've actually got it. Another set of things that are clumped that way are RPD wide communities and registered wide communities. So I need help from folks who are on wide communities, RPD, to help us get the implementation reports and send it out. I will be pinging you individually, but please help us out by doing it. The work's pretty much done. We just need the details in order to send out the Shepherd's report. The following things are in the Shepherd's queue. at the end of working group process, waiting for things to finish off. The NRP draft is waiting for spring consensus on NRP. We've gone back and forth with T's and spring, and we've just got to complete that. The BGP CT SRV 6 also has to have a spring working group okay and some changes. SD-WAN needs a revision based on the routing directorate review. There is some concern in that one because the routing directorate review from ROL didn't miss our templates. We'll go with the templates. And draft ITF IDR VPN prefix CARES got that one ready to go or already sent it up to the ISG. So what about a working group pending? Well, we have many working group pending documents, but please pay attention. If you're on a working group last call pending and you haven't given us what we need, we'll go on to the next one and come back to you in this order. There's first 4370 BIS. After Nate gives us a discussion, Care may start this week. I've given you the reason for this flow spec redirect. The draft ITF IDR next hop was requested to be split away from the entry draft. That's been done. John, if you give me your implementation report, we'll go right forward. Draft ITF RT derived community. G's going to look over it one more time as a shepherd, and we should ship that up. The service metadata is a bit of a chunk of new work, so when we get that, all the chairs will review it. Link local capability will be the same. I heard a rumor that BGP LS ISS flood redirect is ready to go with 2 implementations, but they need to give me another draft. You see the pattern here. We're waiting, so we've queued up a lot, and as soon as we get one, we'll start sending things forward. There is the wide community days I mentioned, the ELC. When John finds a second implementation of that, we'll go forward. The draft ITF IDR BGP FISM IANA needs to make sure the BFD work is done and through the ISG and so forward with the BGP strict. So even though we've got about 13 queued up, we'll still queue up more behind it if you're ready. Now, what about adoption of drafts? We've adopted draft ITF IDR next top nodes, CARES the shepherd, and we also have in process Flex Algo, although Jeff is the shepherd may have already clicked the button because the chairs decided to approve it since the slides. Now, what about early adoption calls? This is my message to people doing BGP SR and BGP LS. We are treating you as a separate category. In other words, I usually try to do as the shepherd in charge of the BGP LS and SR. I try to do the first one, get you through early allocation, and get you ready for working group last call. At that point, I may hand off, depending on load, to one of my other chairs. But my whole focus is to make sure you get what you need to get to the next step. So pay attention. I will have sent you out something at least every 3 months saying do something, and then we can go to the next step. Do not wait. I will take you into adoption. I will take individual drafts into adoption. I will take things into working group last call if you work through the process. Do not think if you saw the other working group last call list that we won't start you up, because the BGP LS and the BGP SR for the most part are fairly well contained. But a lot of these drafts, and I'm for time not trusting that the authors can read exactly what happened and that I sent it out to the list. and a day ago what they need to do. So please, if you're BGPLS, if you're SR, now that's the message for the BGPLS and the BGPSR people. Please just contact me. We've nominated one of the chairs, me, or I volunteered. Watch out for volunteering. Nominated us to take care of you as a group. You have a unique stream into the IDR chairs to get you into the process. Everything goes through the same working group adoption, but we are adopting by category. So do not slow down, get your work done, respond to me, and I will get you through the allocation and the adoption piece and into working group last call. Any questions about that? So adoption requests by category that we have. If you're on any of these categories and you're not there, let me know. We will track it. And this leads me to a thank you. Thank you. I had a personal family crisis over the last 4 months prior to my husband's death last month. So I may have missed something, and Jeff, thanks to he and Kayer and G picked up. But so if you don't see an adoption, let me know. It's my fault. So we have 3 by core BGP that have been requested. Draft Utara IDR BGP OAD, Draft SM IDR Interdomain IBGP, and Draft SANG IDR Tunnel and Cache Label Stack. These are all under review by a specific shepherd for Tunnel and Encapsulation Label Stack because I'm one of the co-authors. Okay, Jeff's telling me to hurry up. Okay, so those are the core. The rest are BGPLS. If you're on this list and you don't know what your status is, or if I've missed you, let me know. I will be dealing with each individual BGPSR person by sending you mail by the end of November. If you haven't heard from me, I will expect you to respond back, so you'll get several mails. Same is true with BGPLS. Flow spec, Jeff and I are going to pick up again once we get that V4 redirect out and maybe some of the other community actions out in the next month. We'll pick up the flow spec work and try to push that forward as our big effort. That's it. Here's the Tuesday agenda. Thank you, Jeff, for telling me I was running over. John, I hope you can give me a couple minutes back. And I think then I need to give the slides back.
Yep, I'll take them.
Okay.
You're up.
You want to give me the clicker?
Of course. We have the power.
All right. Hi, everybody. Hopefully, this is not new to anyone that we, at our last meeting, talked about where to go with BGP. Actually, before I dive into it, I just want to make sure that we are clear on what the ground rules are. This is actually true of essentially any editor of any working group draft, but I feel like for this draft, it's especially important to be clear. I'm not the decider. I am the guy who types and merges PRs. In this talk, I'm going to say some things like, this will be part of the BIS, this will not be part of the BIS. All of these things are proposals. So please keep that in mind when preparing your rotten fruit to throw at me. Okay, so at our last meeting, we talked about let's do the work to get RFC 4271 to internet standard. And we had a really great, I would say, mailing list discussion on this. And consensus was called to go ahead and move forward. By the way, if you get the PDF of this, all these underlined blue things are clickies. It becomes more relevant later. So one of the things that I did really cleaned up over the last few days is to go through and comb through the whole mailing list discussion. And I hope that I captured any issue or suggestion that was raised as a GitHub issue. So I think later on in the talk, I say, please go and make sure your issue was captured. So we need a project plan. We need an agreed project plan. I sort of had one in my head and, talked with the chairs about it and so on, but we need to have it be agreed by the working group. As part of the adoption call, Stefan pointed out, shouldn't we have an agreement on the overall scope? And then Job also made a similar point. We did not choose to close on that as part of the adoption call. So the initial document is just a republication of 4271 plus errata fixes. So essentially the initial document reflects nothing other than things that have already been already have IETF consensus to begin with. But I absolutely agree it's important that we know how we're going to manage this going forward. So in the previous presentation, I proposed some principles, which is that we were going to try to do a minimal revision. As we'll see in the following slides, minimal is getting to be a little big minimal. And also proposed that we manage this partly by integrating things into 4271 bis and partly, when possible, by moving forward separate RFCs individually, so that, as I pointed out in the previous talk, a standard can be more than just one RFC. A standard gets its own number and it can be a group of documents. So getting back to the question of what is our plan, Stefan and Job both proposed putting that plan, having it in the draft itself. We've got a convenient place for it. Section 2 currently says, editors note this is a placeholder. My question is, I don't necessarily love the idea of putting it in there because I kind of would like to have the something a little more dynamic, and I kind of like the, it's still just sort of, early days, but I kind of like the process of using GitHub issues. We'll need to iterate and understand that we are properly keeping the working group looped in on all that stuff if we do it. And I'll take your question in just a second. The one other thing I want to point out is that the draft now incorporates, in the boilerplate, a pointer to the GitHub space. So Stefan, please go ahead. Yeah, so just by the way, let's have this be interactive instead of saving everything for the end. This is
yeah, so that was exactly my point. I think if we just have a pointer to something else, this is completely fine. But at least the document has everything for any reader to be able to understand what we are doing. If we have an external pointer, this is perfect.
Awesome, thank you. So I that is my proposal then, is that we manage that way by having a pointer off to GitHub and having GitHub be the place where we manage the nitty-gritty. And just because I mentioned Section 2, I just want to throw out for anybody's comments or opinions, the reason Section 2 even exists at all is because when I rearranged the document a little bit, Section 9.1.2.2 became Section 8.1.2.2, and that just made me sad. I bet I'm not the only person in this room that has these section numbers memorized. But, it's probably we're just going to have to suck it up and let the section numbers get reordered. But if you have opinions on this, please approach me or, put yourself in the queue or whatever, Kier.
I just had a comment on the one slide back where I agreed with essentially what Stefan said, speaking as a working group member.
Cool. Thank you. Okay, so back to the main topic. So Job Snyder's kindly provided a worked example of how we can maybe, what our working method may be. We had issue 22, which basically said we should integrate RFC 8121. Job provided a nice PR to resolve it, and I think it looks good. I like this mode of operation because it means I'm not doing all the work. And the people who are most invested in a particular thing can maybe have like close attention to it. I encourage people to go look at his PR. It seems like a nice way to work. My one comment is, and I would like to put this out to the working group chairs, AD, is in general, it seems to me like if we're integrating a RFC into the primary spec, probably anything that gets integrated should be made obsolete. So eventually 4271 is going to be obsolete. 8121 is going to be obsolete. We're going to have a very long obsoletes header. It's probably going to wrap, which I'm not sure I've ever seen before. Okay, so this is, I think, mostly what I've just said, but it is useful to have it on a slide and to repeat it. My proposal is we're going to use GitHub issues as a way of proposing work. We will somehow need, and I hope the chairs will help, work with me to understand how best to do this. The mailing list has to continue to be looped in because we are the IETF. We do our work on the mailing list, even if we also use other tools. I think that we don't necessarily, just like editors of a draft are generally trusted to do things like fix grammar and spelling without confirming it on the mailing list. I think we should continue to do that. But anything that's a normative change or even a big, sort of rearrangement of the flow of the document or anything like that, I think we should plan that we are going to loop the mailing list in. There's a bit of a question that we might consider about, do we want to do that sort of in little tiny bites, like every time we merge a PR, we confirm this on the mailing list first. Sometimes, sort of the more traditional old IETF way of doing it is you batch together a whole bunch of changes, then eventually you issue a new version of the draft, and then at that point, then you just wait around for working group last call, and then everybody has a tremendous amount of work to do to review the draft. I'm sort of hoping to front load this process and give everybody lots of little pieces of review work to do instead of saying, however long it is from now, please go and review all 90 pages or whatever it may be. Anything that gets subsumed gets obsoleted. In his PR, Joe basically took the author list and the acknowledgements list from the obsoleted RFC and stuck it in as a subsection under the main acknowledgement section. I think that's kind of a nice way to do it. I think it's good that we don't lose the information about who did all this work that we're folding together. We're going to have a huge acknowledgement section. That's great. We should acknowledge hugely, all of the very many people that have worked on this protocol. Okay. This is maybe the meat of this talk for many people. Things that have been proposed as, or that make sense to me as being rolled directly into the spec. So I don't know if I need to read this to you. I may as well read it out. So AS-wide unique identifier, that's the thing where we say that the BGP ID is a 32-bit int and it's not an IP address. Subcodes for the additional subcodes for the FISM, it could remain standalone, but why? It's nicer to have a single FISM subcode table. This is when I struggled with 7606 revised error handling. That is a big change to the dock, and that was sort of the straw that broke the, camel's back, or broke my will to make this a very, very small update. But it just didn't make sense to move forward with a document that had error handling that the working group has agreed is wrong. So that's going to have to be merged in, I think. And then all the rest of the stuff is relatively smaller compared to that. AS0 processing, the PR that Joe wrote about default policies. The deprecation of AS set and AS confed set is a little tricky because I think we need to maintain backward compatibility, because there are still a few of these things floating around. I'm open to discussion on it. The thing that finally pushed me over the edge to saying, okay, fine, let's put this in, is that I looked harder at 9774, and it does say that you may offer a configuration knob to continue to support these things, which I think is probably just enough wiggle room for us to, keep existing implementations legal. Maybe we need some TTL considerations. Something that I have listed as not part, and the reason I include this is somebody raised a issue against this, is the AS migration mechanisms. That's a standard, and it updates 4271, which is why I think it got the issue. But this is the thing that, where you're aliasing your AS, and you do it when you're merging ASs and stuff like that. And personally, two things. One is it's able to stand alone. The second is, if you remember back to the sort of principles of what are we doing and why are we doing it, it is so that somebody can pick up the spec and be expected to be able to write a decent implementation based on it. I don't think you have to have AS migration to be a decent implementation. And it would just make the spec messy. However, I think we should put a reference to it into the spec so that people know it exists. And then stuff to discuss. And here, let me just go forward one. The kind of all the stuff on this, let's discuss. My concerns are that in order to actually get our internet standard number, our process says there have to be at least 2 independent interoperating implementations with widespread deployment. So for most of the stuff I've listed, I'm pretty sure we have independent implementations, and I'm pretty sure we have widespread deployment. For send hold timer, the ink is barely dry on that RFC, and if people are able to tell me, yes, there is widespread deployment, John, and here's how I know, I am good to include this. And in fact, see the second bullet here, which is we standardized it. I guess we think it should become widespread. That's why we standardized it. So one approach would be go ahead, include it, and then worst comes to worst. It's going to take a while for us to get this thing to RFC. So maybe they'll become widespread, and if they don't, then we can back them out. This is a little bit like the theory that says you can throw yourself off the cliff and maybe you'll learn to fly by the time you reach the ground. But in this case, we have a soft landing available to us. You don't go splat when you hit the ground. Other things to discuss. We have this affy-saffy 1.1 legacy encoding. I wish we didn't, but we do. The conservative thing to do is to just leave the spec alone and continue to specify that encoding. In fact, I think we have to. But we could add language that says something like should not use legacy encoding, should use MPBGP encoding, even for 1.1. I think that I'd be interested in discussion on the mailing list or at the mic about that, but I haven't made up my own mind about how I think that should go forward. Graceful restart, I don't think especially needs to be part of the base spec, except that it does update the state machine. It's got a bunch of state machine patches in there. And it would be really nice to at least rebase the state machine so there's no more outstanding patches against it. So when we start breaking it again, at least we're breaking a clean copy instead of one that's already got patched. So maybe that should go in. And then the final one I noticed, and this I only noticed on a second comb through because it doesn't update 4271, so I missed it on my first go, was there's this avoid BGP best path transitions from one external to another. It basically says make the, instead of falling all the way through to the router ID step of the tie break, just use, most recently used. We could add that, and I don't know. That's why it says let's discuss. These are the things that were, I think, previously all advertised as independent RFCs. These two, we just absolutely need to have them one way or another. If they're not independent RFCs, then they're integrated, but we have to have them because otherwise we don't have IPv6, and if we don't have IPv6, we don't have anything. I kind of think that we really ought to do 4-octet ASNs too, because give me a break. We could go forward with also upgrading the 4-octet ASN RFC. We could go forward and just say we're just deprecating 2-byte ASNs, and the 4-octet ASN is now the first class format. I think that this needs more discussion. And I would be extremely interested in any of you in the room or online who have, are data fans. And if you could contribute any data that says something like, nobody is using 2-octet ASNs on the, 2-octet ASN peering in the world, and I can prove it, that would be so great, because then that would make deprecating it a no-brainer. And a few more let's discusses. Extended message sizes and extended optional parameters length. Again, I think that as far as I know, these do not pass the widespread deployment test. On the other hand, I am completely certain that we will need to have these at some point in the future of our protocol, and it would be really good to sort of push these along. So we need to think about that. And finally, route refresh and enhanced route refresh, I kind of feel like are table stakes at this point. Like they're just assumed to exist in a lot of implementations. So I'm hoping people will go home and review this slide deck and send comments. So just one more thing on the let's publish a bunch of different RFCs instead of just one giant omnibus. Once we sort of jumped in and said, okay, we're gonna fix the FISM and we're gonna fix the error handling section, the update doesn't look so small anymore. So there's like a little less juice to the argument that says let's keep this small and simple. On the other hand, I think Jeff made a really good point on the list when he said what we primarily care about is less how many documents, but whether all the pieces fit together well when considered as a whole. So I think that's still a good argument for, we're going to have a bunch, and we're going to have a bunch anyway. Even if we omnibus everything together, the next day we'll publish another RFC, and then it's still a group of RFCs. But just pragmatically, I think what we do is we first do all the work that was on the, the first slide with the most RFC numbers on it, where they must be integrated into the base spec, and then kind of take a pause, reconsider, and say, okay, do we have the stomach to keep integrating stuff, or are we very happy to just go ahead and republish these as standards? So this is not necessarily a question for the room and the mic right now, although it could be, but this is what I alluded to, is like I would like to understand with the chairs just exactly what process we want to have for managing working group consensus as we work through GitHub. So, work items. All of you, please go look at the list of issues on GitHub. If you raised an issue, please make sure that I captured it properly. If you have new issues to raise, please raise them. And then me, start working on resolving issues. And you, if you want to do some PRs, please do. That would be great. I think my last slide, Keir.
Keir Patel, RK, speaking as a working group member with the chair hat off. IDRP ISO 10747. I don't know about the working group, but it's practically unreadable. I'm hoping we are not going there.
Okay. Can't argue with that.
So we have a few minutes that we're stealing from the Slack. If we have any questions. Now, while we're working through that, one thing that's important to say, we are doing GitHub workflow to make this an easy editorial and tracking process for the working group. You are not required to use GitHub if you are not comfortable doing so. This is why we have editors. Please feel free to either message the list, the chairs, or editor in charge if you simply want to get something addressed.
Absolutely. I should have said that. Thank you. If there's no other questions, I will take my seat.
Thank you, John. Nat, you're up. Let me go ahead and hand the slides to you.
Okay. All right, so I'm Nat Gao. I am the editor of RFC 436 Beeswork, and I'm presenting the updates on this draft on behalf of my co-author. So next slide, please. Okay, the current working scope of this Beeswork includes the following working items. The basic one, the first one is to fix some known errata. There are some known errata regarding this document, so we'll fix them. And the original document is not very clear about the how do we do for the non-transitive extended committee when we're sending them over eBGP sessions, and we will add text describing that. And also, the original document did not mention the error handling procedures explicitly, and the error handling procedure ended up having been defined in 7606. So we'll add a session that refers to 7606 for the error handling procedure for the completeness of this document. And also, we will need to update the IANA consideration section because the IANA extended community registries have been updated by later RFCs, such as 7154. 53, sorry, 53. So we'll need to update that to fit better with the current IANA registries. And we also want to deal with early registry procedures because it's more and more common these days. Next slide, please. Okay, so the current status as version -01, we have fixed all errata. And we have clarified the behavior of eBGP sessions by updating session 6. We have added some text about that, about the RX and TX behaviors. And we also add a session 7, which added references to error handling procedures for the extended community attribute. And also we have updated the IANA consideration section, which includes references to 7153 and 9184 for the updated allocation procedures. And also we have updated the definition of extended communities registries for to better align with the current IANA registries. Next slide, please. Okay, so the next steps are basically we need to address the open issues. So basically, is the added text okay for the eBGP session behaviors? Joe will please review and give us some feedback. And also, does the text align well with the current INR registries? Well, the INR has pointed out several issues during the early review of this document. We will update this document accordingly to solve these issues. And also, currently, we list the original authors in the contributors section. Do we have better ways to do that? So yeah, and also, is the current text okay with the early registry procedure? Is that helpful for the early registries? And maybe we have missed something. Anything else? Please let us know. Okay, so yeah, I think that would be all. Any questions?
Rudiger, you have the cue.
Yes. Thanks. Rüdiger Volk. I unfortunately did not bother to bring this up earlier, but I have been tracking the 32-bit AS numbers back then and was kind of pretty much hurt by it taking so long to actually upgrade the regular communities to something that could actually enable the use in the global internet for the extended AS space. Under 3.1, I'm seeing still 16-bit AS number referring to the IENA distributed thing. And I don't think there is an explanation what should happen if someone was not lucky enough to get a 16-bit number. I never got into a situation where I had to use extended communities. So I have no clue at all where they are actually used and whether this is a practical problem. If this is a practical problem, it should be addressed. And if it is not one, there should be an explanation how to handle it or to deprecate it.
Nat, if you don't mind, I can grab that. So Rudiger,
Sure.
you are correct. The draft in question that we are busying does not itself enumerate the 4-byte ones. There is a separate document that covers that representation. However, the extended community feature only has 8 bytes to do all of its work. This was a motivation, and the primary motivation for 4:4 style formats for the large BGP community. So for general purpose operator use, large communities have addressed this. For VPN purposes, we do have limited use cases for it. At this point, is not considered a problem for VPN type applications or things that normally want to use registered extended communities. But a very fair point is that this document should talk about the presence of these 4-byte things, and please point to them. So we will take that as an issue.
Okay, thank you.
Nat, thank you for the presentation. And for the working group, please thank Nat for taking up this piece of chartered service. Thank you.
Thank you very much. Thank you.
Okay, we should be moving on to the first presentation from Stefan.
So the first one is IBGP DMZ.
If you may take the clicker, I will share it to you.
Okay. So this presentation is an update about the IBGP DMZ draft that we have in BES. So as it will displayed in the conclusion slide, so there has been discussion during the working group last call of the link bandwidth draft about having the use case which are described in this draft to be moved in IDR and so on. But anyway, whatever we finally do with this draft, it's really helpful to have, I would say, the latest information discussed in this group as well. So just as a reminder, so the main focus of this draft is to highlight a couple of use cases of the BGP link bandwidth community. And basically, we have behaviors about how do we set this actual BGP link bandwidth community and what are the values that we set to it, and how can we also tweak locally in the box the way we do the weighted load balancing. So what are the main updates? So in fact, the main link bandwidth draft was idle for a long time. This draft started to pop up due to mainly use case in the large-scale data center and how to optimize the WIN CMP in this kind of behavior. It started to come with some gaps that the BGP link bandwidth draft had. So there was some text added to, I would say, complement the behavior that were not addressed in the initial spec and so on. But now the BGP link bandwidth draft has progressed to its last state, and a lot of text that was in the eBGP AMZ draft was absolutely not accurate anymore. So we had to trim all these things to because now mostly everything and all the changes that were required to the BGP link bandwidth community are addressed in the base specification. The other thing that we have done is we have clearly separated the use case. So for instance, this eBGP-based data center, or how can we use the BGP link bandwidth community into, for instance, ISP and peering scenarios and so on, versus, I would say, the new behaviors, I would say local behaviors that we are defining and that I will talk just after. So the draft was also initially informational, but we are evaluating the possibility and we are proposing to make it back to standard track, especially because all these, I would say, local behaviors are now implemented by multiple people. So yeah, even if it's local, it's probably better to get it as a standard. So the typical scenario, but it's not the only one where it could be useful, is this eBGP-based DC fabric. So let's say we have DC1 and DC2, and basically each data center has a couple of aggregate prefixes, and these aggregate prefixes will have to be propagated across the data center. And the goal is to perform WACMP at each level of the data center, so the tier 3, the tier 2, and the tier 1. So the question is, first, how do we initially set the link bandwidth value? And because we are changing the next stop at each layer, what is the new link bandwidth value that we will actually propagate down to the servers? So step 1, how do we initialize the BGP link bandwidth? So one easy way that a lot of implementations are already doing is if we consider that this is an eBGP based fabric, so we have eBGP sessions directly connected links. So we can basically discover what is the interface bandwidth associated with this eBGP session, and we actually set this interface bandwidth into the link bandwidth community. So for instance, initially DC2 is advertising the aggregate without any link bandwidth, but when the top level aggregation routers are advertising back these aggregates down to another data center, they are setting the link bandwidth attribute using the actual egress link bandwidth that they have. So let's say AG1 has a link to DC2, which is 800 gig. So it will set the link bandwidth value to 800 gig. And if, for instance, AG2 has a bundle of 4 times 100 gig, and if we consider that, for instance, one of these bundle member has failed, it will actually send 300 gig available. So of course, it's something which is dynamic. So each time the interface bandwidth is modified, a new BGP update will be actually sent to update the bandwidth advertised to the T1. Of course, it's not a default behavior, so this is usually something which is enabled by configuration. Next thing is when this T1 is actually receiving this BGP updates with a link bandwidth, how do they actually do weighted ECMP? So if we consider just the base link bandwidth draft, the base link bandwidth draft is telling, okay, I'm receiving on one side 800 gig, on the other side I have 300 gig. So I will compute some weights based on that, and I will send some percentage of traffic on AG1 and the other percentage of traffic to AG2 using this bandwidth ratio. However, if for instance, like it is displayed on this figure, if my local link between T1 and AG1 is just 600 gig, and if for instance T1 to AG2 is 400 gig, if I just use the ratio based on what I have received from the link bandwidth community, I may create some congestion. So there are some situations where we actually need also to take into account the local link bandwidth, okay, and not just the ones that we are actually receiving. So this is why in this draft we are defining a couple of notions. So we call the remote bandwidth the actual values that we receive from the extended community. The local link bandwidth is the one that we are discovering from the interface manager. And then we need to evaluate our contributing bandwidth. So the contributing bandwidth is the values that we will actually use to perform our WECMP, okay? And then it's really up to the user through some configuration to define what do we need to use. Okay, so do we need to use what I'm receiving from the other one because I don't care about my local bandwidth because I know that, for instance, it's a local fiber, it will never fail or whatever? Or do I want to use purely the local? Because the issue is that when I'm propagating the remote bandwidth down to all the layers, any event that is happening really far will be reflected down, for instance, to the server. And sometimes we want to hide some of this churn. So yeah, we may want to decide to just take into account the local bandwidth and we don't care about the remote one. And the other, and possibly one of the most interesting use case that I was presenting earlier is we do some mathematical function between the two. And the biggest use case is we just compute a minimum, okay? So I have the remote one, I have the local one, I compute the minimum, and theoretically it's giving me a good result. And the last use case is, again, if we do step by step, we did the initialization at AG1, T1 is performing some WECMP, and then what is the value that T1 will actually send to T2? And this is where the cumulation mechanism is taking place. So we consider that we have multipath, so T1 is doing this weighted load balancing. So we could consider that, let's say, this T1 as, let's say, if we consider that in this example, it takes only into account the local link bandwidth, so it's performing, for instance, WECMP using 600 and 400, it may tell to T2 that it has actually 1 terabyte of bandwidth available, okay? Which is actually true because the total amount of bandwidth that it can send traffic on is actually 1 terabyte. So this is a process of cumulation. So we take the bandwidth, the contributing bandwidth that we have on all our members, we cumulate it, and we tell to the neighbors that we have this amount of bandwidth available. Yes, please. Yeah.
John Scudder, I just want to make sure I've understood it right. You said you've got 1 terabyte available. Don't you have 900 gigabytes available? Because
yeah, it really depends on what is the source of information. Okay, so I agree. If you use your contributing bandwidth and your contributing bandwidth is based on the mean, it will be actually 900 gig. Okay, but then again, if you want, for instance, to hide churn or things like that, you may decide to do your cumulation not on the mean of the two, but on something else. Okay? But I completely agree. Yeah.
Jeff Ventura, NVIDIA, if I may.
Yes, please, Jeff.
So implementation-wise, what we usually do, we take value multiplied by number of next hop received from. So in this case, given that if we take like every link 100 gig.
I'm not really able to hear you well, Jeff.
Let me try to get closer to the mic. So in implementations, what we usually do, we multiply value received from the peer by number of next hops it has been received from, assuming all the links are of the same speed. So say in the previous drawing, we'll have 6 links on one side and 4 links on another side. Multiplication ratio is 4 by 6. So this is the ratio that would be advertised to tier 2.
Okay.
That's what has been implemented by most vendors.
Okay.
So that's one comment. I would really like to see this progressing as standard track as both implementer and users. The feature has been deployed in largest network in the world at huge scale. It relies on existing behaviors. It's been working really great for the last 3-4 years. We absolutely need to standardize it so there's no deviation and stuff doesn't fall apart. It's really, really important.
Thank you for the conclusion, Jeff.
I'm massively using it, so I'm personally interested.
Okay. So I don't see anything else in the queue. Thank you for the presentation. And there's the open question that's been discussed on the mailing list, between the BEST chairs and the IDR chairs of where does this document live? I will repeat my comments at the BEST session, which is it's less important about where the document itself lives, aside from resolving things from a process standpoint. This work is absolutely co-owned between IDR and BES, and BES is driving not only many of the current use cases, but also setting up the stage potentially for future use cases that may need a different encoding. So we will continue the discussion among the chairs and on the list. Meanwhile, please lend your eyes to help review the last sets of cases, and we'll hopefully advance this to last call very shortly.
Thank you. I'm also the next one.
You are?
Yeah.
But I have to take it back from you to do that. Your tools are not friendly. There we go.
Okay, so next presentation is a very, very old draft, something like 10 years old that we are trying to revive. And it is about some limitations that we have with the RT constraint specification in case of inter-AS. Okay, so what this specification is actually telling is when we receive some inter-AS NLRI, we are only picking up the best path. And this is, I would say, this is creating just a single branch of distribution for this particular route target. While this is giving, I would say, some very good optimization in terms of footprint of VPN routes across the nodes in the network, it has some caveat. Okay, so if we look at, for instance, the picture which is actually displayed, so it's a typical inter-AS case. So let's say we have P11 on the left side, which is interested by a particular route target. So it's propagating an RT NLRI through the entire network, and AS2 is actually receiving it. So what's happening is the first level on the ASBRs of AS2. So if we consider, for instance, ASBR 22, which is actually receiving 2 paths for the RT NLRI, because it's an inter-AS NLRI, it will pick one best path, which means that the VPN route distribution for this RT will be done just to a single peer. Okay, so for instance, let's say ASBR 22 is the best path for the RT NLRI. The VPN routes for this RT will be sent only to ASBR 22. Okay, and possibly the same thing will apply on the route reflector. I have some caveats that I will discuss later about, I would say, interpretation of the RFC and differences in implementation. But basically, we can consider that the same will apply on the route reflector. Route reflector is getting 2 paths, ASBR 21, ASBR 22, and it will pick the best one. And this is creating a single branch of distribution through ASBR 21. There is a big typo in this slide. Sorry for that. There are 2 times the same numbers. Okay, so at the top, we have a single branch of distribution. So the routes, for instance, let's say P21 is sending VPN routes. These VPN routes will be received in AS1 only through ASBR21. Now, what is the issue? It's working. Connectivity is absolutely working in this case. However, what you get a very slow convergence. If ASBR21, one of the two, it doesn't matter, goes away, you will have to wait for RTC best path computation to apply. Then a new branch of distribution will be created, and then you will get the VPN route. It will work, but super slow. The other thing is you may get suboptimal routing, because if you think that all these ASBRs are located in different regions of the world, for instance, how can you do, I would say, really precise routing of your traffic depending on the region and so on? It's just picking one almost randomly, okay? And one of the biggest issues, and this was the original use case of this draft, is if you have a topology like this, okay, so you have, for instance, multiple data centers that are running ASBR option B to a core network, and because operators don't want to care about managing the AS number, they put the same AS number everywhere on the data center. So for instance, 65,000. What will happen in this case is we are not able to propagate the route across the data center because, again, let's say they're interested by the same RT, so they will each of the data center will send the same RT and LRI. VRR will get 2 paths for this RT and LRI, and because it's inter-AS, it will pick 1 path, which means that this RT can be distributed, for instance, just to DC2. But DC1 will never get these VPN routes, okay? So it's not just theoretical, it happened in a live network. So what is our proposal? Something simple, and at the end, this is something which has been already implemented by a couple of vendors for a long time. So what we need is we need to be able to consider multiple paths and not the best, only the best one for these inter-AS and LRIs. So there could be multiple strategies. One is to do exactly the same thing as we do for intra-AS, which is I'm considering all the paths and I'm distributing everywhere. So it perfectly works, and it's again a trade-off between, I would say, distributing VPN routes everywhere. So you lose a bit of optimization in terms of footprint versus the optimality, resiliency that we want. There could be additional options. As it's a local behavior, I would say it's really up to the implementation to propose something. We can, for instance, say, I want to propagate just the best and fix second best. There are multiple things that are actually possible. One thing that this draft is also highlighting is, due to some ambiguity in the initial RFC, we see 2 different flavors of implementation regarding the inter-AS behavior. The first one is what we call the per NLRI type pruning, which means that this inter-AS behavior applies whatever I'm receiving the route from eBGP or IBGP peers. What matters is the origin AS of the RT and LRI. If the origin AS of the RT and LRI is different from my local one, I consider that this is external, even if I receive from IBGP, okay? However, the other flavor of implementation is per type pruning. In this case, we don't really care about the origin AS. What matters is, do I receive from eBGP or do I receive from IBGP? If I receive from eBGP, I do pruning. If I receive from IBGP, I distribute everywhere, okay? So next step, of course, we welcome the feedback. So for this version, the text is almost the same as the 10 years old. We just did a bit of cleanup, make it probably a bit more readable. Again, it's something which has been implemented for a long time. So we would like to request a working group adoption for this one. Thank you. Any question?
Okay.
Next one, still me.
Yes.
Okay, so let's talk about this one. So BGP, best path, next stop selection. Again, you will see it's not something new. It's something that a lot of implementations are already doing for a very long time. What is the problem statement? The problem statement is that BGP RFC 4271 has been initially designed for purely hop-by-hop IP routing networks. Okay, so we have this next stop attribute. So when I say next stop attribute, it can be the real attribute of the next stop field of the MP reach and LRI, it doesn't matter. But we use this, the assumption is this next stop is the actual guy to which I will send traffic to. But and this is why we do all these resolvability conditions. So can I resolve this next stop in my routing table, which is the first step. And then when I have multiple IBGP paths, I will pick the one which has the lowest metric, which is absolutely fine for the regular hop-by-hop BGP case. But fortunately, unfortunately, we have a bit messed up things. We have created a lot of new data planes. We have done MPLS. We have done segment routing. We have done SRv6. We have a tunnel on cap where we can encapsulate things on whatever tunnels and so on. Which means that our actual next stop, it's no more really the guy to which we are sending traffic. Okay? And because of that, if we just use the base specification of BGP, we can end up into some weird thing, which is I can either drop traffic because I'm checking the next stop, but I'm not checking the real guy to which I'm sending traffic, or I can have some suboptimal routing. Okay? Again, it's not a new problem. A lot of implementations are already implementing things to actually get this behavior fixed. So the goal of this draft is really to, I would say, document what is already existing in the field. So let's take an example about traffic drop. I will make it easy. All these examples are MPLS based. So let's say we have a VPN network. We have P1, P2, and with multi-homing to a prefix, which is P/M. And we have P3, which is receiving two paths, one from P1, one from P2, and we have a label because it's a VPN route, okay? So we have this two paths in the BGP table of P3. So if I consider the base specification, I should theoretically look at my routing table, if we consider my IP routing table, to check if P1 and P3, P1 and P2 next stops are reachable. And here, for instance, in this example, they're reachable. I have a route, for instance, an ISIS route, an OSPF route to be able to reach these guys. Okay? So in this case, if I just use the base specification of BGP, my next stop resolvability condition is completely fine. However, let's look at the what we could call the tunnel rib or tunnel table or whatever. So what are the actual LSPs that I have to these guys? So in this particular case, I can see that, yeah, that's fine. I have an LSP to N2, okay? However, for whatever reason, any control plane signaling issue, my LDP session are down or whatever, I have no LSP to N1. And because I have no LSP to L1, and if we consider that the cost to actually reach N1 is lower than the cost to reach N2, N1 will be picked up as best. So BGP is picking N1, but I don't actually have any forwarding path to send to N1, which means that we are actually dropping traffic, while there is an alternative, which is using N2. Now, suboptimal traffic. Let me complexify a bit the example. We use a color extended community to tell that my particular prefix P/M needs to use, let's call it an intent from a marketing perspective, which is I want to use a low delay path, okay? And in this example, we leverage SR policies, let's say, to deliver this low delay path. Again, what's happening? My current routing table, so IPv4 routing table, is telling I can reach N1 with an IGP cost of 2. I can reach N2 with an AGP cost of 6, okay? However, if I look at it from an SR policy point of view, my SR policy C1, N1 has an actually delay of 12, so a metric with a metric type delay which is 12, and C1, N2 has a delay which is actually 4. So the lowest cost next up from a low delay point of view is actually N2. It's not N1. But again, if we use just the base BGP specification, I'm looking at the cost in RIB, and the cost is telling you that N1 is actually the best one. But N1 is just the highest delay. Okay? So we are not really fulfilling the intent. So I provided a couple of examples with MPLS, but it's a generic issue. This has nothing to do with MPLS. We have the issue with SRv6. And for instance, the 9252 already fixed as part of its specification the fact that we need to look at the reachability of the seed in addition to the reachability of the next hop. We have the issue with tunnel on caps. Again, 9012 is telling that we need to have a feasible tunnel if we have a tunnel on caps attribute, not just checking the next hop, which is good. And for MPLS, there was a very old draft as well, which is this best path selection criteria, which is telling that, I don't remember the exact word, but something like, we need to look at the proper table, the proper forwarding table to, instead of just looking at the RIB. So from a resolvability perspective, resolvability condition, at least for this 3 use case, we were almost good. What is really missing is this path suboptimality that no one is talking about today. So what we are trying to do is to define some kind of generic concept that we can reapply to many different things afterwards, because whatever it's SRv6, tunnel on caps, and the behavior that we want is exactly the same. So first thing is we need to identify when I receive a BGP update, what is my actual forwarding address. So this forwarding address could be the next stop. So the address which is in the next stop attribute, which is the default case, but it could be something else. If I have tunnel on cap, it may be my tunnel, it will be my tunnel endpoint, okay? When I have this forwarding address, I need to find the characteristics of the forwarding path. So this is what we are calling the forwarding context, okay? So for instance, it could be, again, in tunnel on caps, what is my tunnel type, okay? Or what is the, if it's VXLAN, what is my VNI? Because all of this will allow me, first of all, to, for each implementation, to do the lookup in the proper table, and also possibly adding additional constraints. So this is why we introduce also the notion of resolution constraint. So we need to do the resolution, but this resolution has some constraints. What table to use? What path characteristics I'm looking for in this particular table, and so on.
Stefan, you're now over time.
Gosh.
So if you can zip through the important pieces.
Yeah. Basically, so what we propose in 2 minutes is, first of all, creating some generic concept about this resolvability condition. So we do the resolvability condition on the forwarding address on top of the on the next stop one. And the second one is propose an option also enabled by configuration modification of the internal cost computation. Okay? So we can actually get the actual cost from the particular table associated to my forwarding, not really entry, but object or something like that. However, there is another thing is, if we start to get cost from different things, so for instance, I have a cost from an SR policy, I have a cost from an SRv6 things, how this cost could be comparable, okay? You can compare things that are I would say common, but if you don't have any common reference, you cannot compare any. It's exactly the same issue that we have in the routing table. So this is why we also introduce the notion of preference, which is nothing more to something which is similar to the administrative distance that we have in RIP. So we first compare the administrative distance. So we compare things that are not comparable together. And then when it becomes comparable, so it's the same type, I can compare the cost. So this is just what I explained. And one very small thing, of course, it's not something that we need to do just one time when we receive the update. Each time, all the implementations are doing that. Each time there is a change in the cost, in the reachability, BGP path computation needs to be redone, obviously. So next steps, we are welcoming feedback. For us, it's just about documenting things that are existing. It's a well-known problem. So yeah, let's make this moving forward.
Hey, K. Patel Arcus, couple of comments. This is actually very important work, and we should consider fast tracking it because it does solve a certain problem. Now, the second thing is, which I sent it out to you, you need to be very careful to make sure that the algorithm in itself is uniform inside a domain. The third thing is that otherwise it'll start in a hop by hop scenario.
Yeah, each time you are tuning something like preferences and so on, you can end up into creating loops.
So
I agree.
But the standards has to have defined in some way that you are in sync.
Yeah, let's discuss.
The third thing is about the tunnel encap part that you said. Well, the assumption is you should have a common IGP, otherwise different encaps will lead you into a different sort of issues that you need to normalize it, which you rightfully said. Last point, and actually a question for you as a best chair. I think if you do VPN v4 over 3107 over ISIS or any IGP, you would see exactly this problem, except for the fact that 3107 carried loopbacks which were pointing to only one router. But had those loopbacks had multiple paths ever in the network, the normalization would have resulted into some kind of...
Absolutely. Yeah, I agree. Yeah.
Which you agree, right?
Thank you.
Bruno is up. And a very quick note, if you have not used the QR code to sign in, please do so that we may get the appropriate sized room.
So hello. The draft is about BGP error handling for the specific case where you have error in the NRI field. Oops, some delay. So BGP error handling is defined currently in RFC 7606. It is specifying three approaches. One is attribute discard, which you can do if the attribute in error has no impact on routing. Second approach is to do tree test withdrawal, which you can do it if you can actually do a withdrawal. So if you can read all NRI in the BGP update. And the third option is to do BGP session reset. So we can see that for the two first approaches, the scope of the error is limited to the BGP update in error. And the third one, you lose all your routes. So if you want to avoid session reset, it's absolutely critical to be able to parse all an NRI in the message. Now with MPBGP, we may have multiple address families. And for some address families, they encode in the NRI two or multiple fields. One is the key, which is usually the IP prefix. And some other data, which are sometimes referred to as non-key data. Typically, it's some kind of data stuff that are expected to be specific per NRI. Example of such address family is label unicast, originally specified in 3107, which carry both an IP prefix, which is the key, and MPLS label stack. And we also have derivative, I would say, address family using the same encoding, such as BGP-CT and IPVPNs. Another example is EVPN from a base working group, and more recently in IDR with BGP-CAR, which has proposed a very, I would say, generic and powerful way to encode the non-key data. And here on the figure, we have just one NLRI, and we can see that we have multiple fields, multiple lens fields, so two at the beginning, plus all the TLVs. So for such address families, when we have both that non-key data and key, clearly the size of the attribute, the size of the NRI is bigger, which increase the size of the data to parse, so the probability of error. We also have more parsing complexity because we have multiple fields. We also have multiple length fields, multiple TLVs, and we may also have some innovative way to encode the field, such as the length of the field, such as the MPLS end of stack bit. So 2 reasons to have more chance of error when parsing the MP rich NRI, and then to trigger BGP session reset. On top of that, on top of losing all the routes, the BGP session restart is not likely to help because when the session restart, you get the same routes, same NRIs, same error, same reaction. So in conclusion, you have a high network error impact, and which require human intervention quickly to find a solution, to find the error on the solution. Very likely, there is an implementation issue either on the sender or the receiver. So you will also need a software fix, validation, deployment. So what is the proposal? It's quite short. It's stand on one slide, 2 bullets. First, it defines a new non-transitive BGP attribute, which is currently called NLRI key list. The format is exactly the same as MP enrich NLRI, which is a withdraw. So no need to respecify this. It's applicable to all existing and future address family. And we propose to encode it first in the update to maximize the chance that the error will be further down the update. And then it is proposed to be followed by MP rich in NRI because RC 7606 asks for that for exactly the same reason. So that's the encoding. In terms of behavior, relatively simple. If you have an error condition in the MP rich in NRI, which prevent you from reading all NRI, you do a treat as withdraw by using that NRI key list attribute, which is actually a withdraw. And with that, you can avoid the session reset. So it's straightforward. We reuse the existing MP enrich NRI format. So the sender construct the NRI key list as a regular MP enrich NRI. And the receiver, if needed, reads as MP enrich NRI. There is some extra complexity, obviously, on the sender, mostly the need to encode twice the list of NRI, once for MP rich and one for NRI key, plus the cost of implemented, the cost of the bytes in the updates, and CPU time to construct. But it's optional. And in my opinion, the good property is that the cost of that attribute is supported by the address family, which brought the additional complexity of the non-key data. So you have the advantage, you pay the price. Let's have a look at an example. This is a VPN network on the right. So some PE, some route effectors. In the circles, each circle has a color, which means it's a different implementation. If you don't see my colors, so you have P2, P3, P4 in red. P1, RR1, P5 on the left are in black, and RR2 in green. So the scenario is P1 advertiser route, BGPLU, with a label stack of 2 MPLS labels. You have the detail of the encoding. I will skip it for because I don't have much time left. But you have all the fields of MP rich and NLRI. And in particular, you have the 2 labels and the 2 bottom of stack fields. So the scenario of error is that one implementation, the one in red, actually does not understand the MPLS label stack. It assumes that there is a single label always. So P1 originates the root, RR1 and RR2 propagate the roots. So far so good. It's all fully as specified by 3107. Then the roots arise on P2, 3, 4. They cannot pass the NLRI because they first the first label and they cannot locate the second label and the IP prefix which is after. So they have to do treat as withdraw on session reset. Unfortunately, we see that redundancy does not help. We have two root effectors. We could have three, but we lose all sessions. And also code diversity does not help either. We have two diverse code for RR, but we still lose all PEs in RAID. So if your network have 50% of PE in RAID, you've just lost 50% of your PE because of one single root. And since a flow is coming from one source to a destination, actually you lost 75% of your flows until someone find a fix. So the new proposal is just to add the NLRI key list at the beginning, which encode an unrich MP unrich NLRI. And we see it's shorter than the MP rich in terms of size, definitely shorter in terms of number of fields. And thanks to that attribute, the P2 and P4, which cannot parse the NLRI in the MP rich, will be able to do a treat as withdraw using the actual withdraw, which is encoded in NLRI key list. So the proposal really builds on the fact that MP unrich NLRI is shorter in general than MP rich. And especially for address family with non-key data, it's both shorter and simpler. Just on time, next steps, we would welcome a review from the working group on comments on the draft. We'd like to thank the reviewer on 0.0.0 version. We just published a 0.1 before the deadline. So we would like to solicit review again, please. And we'd like to ask for working adoption.
So thank you, Bruno. This did get a lot of very good discussion on the mailing list and has generated a lot of very strong opinions. So if you do not have specific questions for Bruno right now, I'd like to request you please take a look at the 0.1. Let us then have the debate about what we feel about using this as a resiliency feature. Last chance for questions. No questions. Thank you, Bruno.
Thank you.
John, you're up.
Hi again. This will be shorter than the last one. We have a working group draft called Draft IETF IDR Entropy Label, which is kind of a misnomer. But anyway, just very briefly, because we've talked about it many times, it contains two things. One is a attribute which can contain these things that we now call characteristics, which basically describe something about the forwarding plane characteristics of a route. And it's got some mildly novel safety features. And then this draft also contains the entropy label characteristic, which was kind of the thing that first prompted pushing it out, which has to do with telling the receiver, oh, the guy on the other end knows how to process entropy labels. And this is, again, kind of a truncated history because it only goes back as far as working group adoption. There was like mergers and other things that happened before that. But we adopted it in September of 22. We finished working group last call in November of 23. And since then, we've been hanging out in waiting for implementation. Since then, we've got at least, we've got 3 specs that are using it and have requested code points. So if you look at the IANA considerations section, you'll see multiple code points listed in the seed values in the table. 2 of them are already working group documents. I think the third is finishing an adoption call, if I understand right. And this isn't great to have a whole bunch of working group documents that are based on a document that's stalled. At some point, if nothing else, we're going to end up piled up in a hairball at the RFC editor end, and with everything just blocked on the base document for publication. But probably more important than that is we need a registry. It's not great practice to manage our code point space by means of just asking the authors to flip me a code point, please. And it's not terrible, but it's not best practice. So we do have 2 implementations of NHC because of next hop nodes. So we meet the working group requirement for 2 implementations for the base thing. We just don't meet it for the entropy label bit. The most straightforward way to fix this was to split the draft. So we did. I published 2 individual drafts so everybody could have a look and see what we had done. The chairs did a consensus call and nobody said stop doing that, so we did it. So now what we have is we no longer have the 1 old working group draft. We have 2 new working group drafts called NHC and called ELC. And there really isn't anything more to it than that. You put the 2 of them together, you get the old one. It's almost as simple as just pasting them together. I mean, not really because of boilerplate and stuff, but there's nothing added, there's nothing taken away. So what I think we should do next, and Sue also nodded to this in the status slides. Thank you, Sue. We have 2 implementations of NHC, so we will go off and update the implementation report now that we have working group drafts to report on. Then once that's done, we will request that we reconfirm the working group last call, and then let's get an RFC number for that thing. I have also heard that there are other vendors that are actually going to do ELC, but who knows when they will be done because you know how things go. But it's not blocking anything. So, I would love to have it get an RFC number in 6 months, but if it's longer than that, okay. That's it. Any questions? Thank you.
Thank you, John. And this actually catches us up. That said, we will be slightly reordering the schedule so that Srihari goes next. He got shorted a little bit the last presentation. And I will take the last slot. And if we go over long, I will be moving to Friday.
All right. Thank you, Jeff. Hello. Can you hear me, Jeff?
We can hear you.
Wonderful. Okay. All right. Hello, folks. This is a presentation on enhanced dynamic capability for BGP. This draft has been out there for a few, since last IETF for maybe a few months. And this is a presentation about what this really brings in. And I'm presenting on behalf of my author, Enki Chen, and I'm Srihari Sangli from HPE. All right, so the agenda is I'm going to introduce what the problem this is trying to solve, what already existing mechanisms that we have to sort of solve this problem, and really explain what this dynamic capability, enhanced dynamic capability is all about with next steps. All right, so the whole problem is all about there are many capabilities that change the format of a message once it comes into effect. The examples are you have add path or 4-octet AS. And as of today, these capabilities are exchanged via open message. And therefore, anything that we need to change or add or revise these capabilities, we have to go reset the session. And reset the session is bad. We all know that. All right. So, like I said, one way to enable or revise this capability is through open message. The problem with that, the other option that we have is the existing dynamic capability draft that was presented in the last few IETFs, the CAP 17. But we have the limitation there that those capability, that mechanism does not support capabilities that change the format of the structure of any of the message. So effectively means that we do not have any solution for enabling add path kind of capabilities dynamically. All right. So what we're trying to propose here is this is a new capability, and this is going to be announced in open message like any other. It also introduces a new message, and like the dynamic capability message, this enhanced dynamic capability message, the dynamic capability lists all the capabilities that the local peer is allowing the remote guy to revise. Right. Now, this enhanced dynamic capability supports all capabilities, not just the add path kind of capabilities, but also applicable for, you name it, route refresh or multi-protocol extensions and things like that. Now, because this is a capability, this can also be revised by listing the enhanced dynamic capability in itself. So this can be used for revising the entire set of capabilities, and this can be useful in a hitless upgrade scenario. At a very high level, this enhanced dynamic capability, structure is what you see on the right. We are proposing 4 different subtypes within it. The init and the ACK conform is what the initiator is going to use, and then the ACK and the NACK is going to be done by the receiver. Initiator is the one that initiates the revision, and the receiver is the one that. Are you able to see the slides? I see.
The slides have stopped. I will reshare.
All right. I was presenting the 3rd slide or the 4th one. Yeah. All right. We talked about the init, ACK, and the ACK confirm the NACK. And for each of these messages, we are proposing the additional information that can be sent. For example, the ACK and the ACK confirm can send what is the demarcation. I'm going to explain some of these things in the next set of slides. And the NACK can send multiple reasons as to why the receiver is not acknowledging the revision of the capability. All right. So from a multi-instance capability, the existing RFCs already talk about, like, for example, the MP Reach RFC talks about what is a multi-instance capability, which is you have a MP Reach with individual address families, office. But there are certain capabilities, for example, add path, which do not specify office, but it is almost integrated within it. So any capability that has office-ness in it, we are considering that as a multi-instance capability. And what we are allowing is, if you want to revise a capability, it has to be at the granularity of a multi-instance of a specific instance, for example. And you could remove the entire multi-instance capability where all the sub-instances could be removed altogether. Back-to-back revisions can be supported in a restricted way, which is if a single instance is being revised, let that complete, and only then you can reinitiate another revision of it. Like, for example, you want to add and remove, let the add revision complete before you remove the same instance. However, two different instances can be revised parallelly. We are introducing a demarcation indicator. What this means is this will indicate whether the capability is going to get into effect, right? So when I'm going to advertise a message with the demarcation indicator, I'm basically letting my remote peer know that I'm going to start using the new format, especially the add path, for example, that I'm going to use the path ID in my next update. And who sets and when does DI get set for a unidirectional capabilities? And unidirectional capabilities are those that have just the route refresh kind of a capability where I don't need to check whether the remote guy is also going to be enabling the capability. Whereas bidirectional capabilities are those that need to have both the peers do the same updates, do the same capabilities, right? For example, add path, you have to have the both sides enable the add path for you to really have a meaningful conversation. So for unidirectional capabilities, receiver just sets the DI in an ACK message, whereas in the bidirectional capabilities, both the peers check whether the two ends have enabled, and therefore they will set the demarcation indicator either in the ACK message or in the ACK confirm message. All right, so the procedure for capability revision, looking at the add path kind of a capability, the initiator, the router which starts the revision, let's say the router sets adds or removes the capability instance, and this message is sent as an init message. It reaches the receiver. Receiver has an option to either acknowledge or reject the revision. If the receiver chooses to acknowledge, sends the ACK message, and in that ACK message, it has the option of setting the demarcation indicator, right? And for the ACK that comes to the initiator again returns back an ACK confirm back to the receiver. So there is a init ACK and ACK confirm messages that float between the initiator and the receiver. In case the receiver does not want to accept the revision, it will NAC. And then the NAC can have so many reasons as to why the receiver is not ready or does not want to accept the revision. All right. So given that the states are exchanged, when do we bring in the capability into effect? The key here is this is applicable for bidirectional dependent capabilities, for example, an add path. So for a router, the initiator, which is trying to initiate a revision of the dynamic capability, it can only do, like we talked about, it can only do if the receiver has allowed the that particular add path to be revised, right? So it's going to initiate add path to the remote peer, which is the receiver. So receiver checks for bidirectional dependency and marks the demarcation indicator. Now, when it tries to do that, it will go through these logic, right? So the revision is accepted and ACK is sent back to the initiator. That means the receiver knows it can handle the add path and it is acknowledging the initiator's revision request. But there are a couple cases. Let us say the receiver has already enabled via the open message, in which case the receiver is already ready to talk the add path. So therefore, the demarcation indicator can be set in the ACK message itself, right? In which case the entire FSM is complete. In case the receiver has not initiated this in the open message, it's going to do the same thing through a init and the add. The receiver will again, at some point of time later down the line, will do the initiate by revising the add path capability, in which case the add or the init from the receiver comes back to the initiator, the former router, with the ACK request, and then ACK throws back, and eventually the receiver will send the ACK confirm. At that point of time, it is confirmed that both the ends have the capability enabled, and therefore demarcation indicator is indicated in the ACK confirm. So that's the bidirectional dependency that needs to be checked on both. Similarly, on the initiator, let's say when the initiator sends the init request for adding a capability, it has to again look for bidirectional dependency for bringing that into effect. Now, it will have to wait for the receiver to accept the revision and return back. That's one. But then the ACK will come back to the receiver, the initiator. The initiator has to send the ACK confirm. So only after sending the ACK confirm is the one check that the initiator has to look for. And then the question then is, is the receiver already has advertised via open message? If it is the case, then FSM is complete. Then the demarcation indicator is set in the ACK confirm, and the capability can be put into effect. In case the receiver has not done through open message, then we are expecting the receiver to do another revision from his side, in which case it is going to be through ACK that the initiator will be sending for the receiver's revision, and therefore after sending the ACK, it can put the capability into effect. With this, what we are expecting is the session will not be reset, and the messages can still be exchanged in the, let's say, take add path as an example. The old format can still be exchanged, and until and unless the demarcation indicator is exchanged between the two, the add path can be put into effect, and from then onwards, we can switch over to the new format, and we'll be able to exchange the messages without resetting the session. So this is my last slide. We do have a couple updates that's going to go on the draft. There we have put many use cases for various scenarios and shown the state diagrams, FSMs. There are a couple things that we'll update, and we'll also have a implementer's note, the paragraph into that, so just so people get better clue as to how to implement this. So with that, I want to see any questions people have.
Do we have any questions for Shari, who has a very nice shirt? Okay, I don't see anything on the mailing list. Thank you, Shari.
All right, thank you. And I'll request chairs to, for adopting this work. Thank you.
Thank you. So I am the last presentation of the day, and I will attempt to keep this within the time that we have available. So I'm giving this presentation on behalf of my co-authors, Kevin Wang, Chung Wang, and Jeff Dansura. I will be very brief through a number of these points because many of these things will be familiar to the working group. Why isn't that clicking? There we go. So global load balancing is very popular as a topic right now for BGP fabrics and other things implementing no-flow topologies. We tend to see these things, especially in the folded 3 and 5 layer flows. Question is, what do we do about standardizing these sorts of things? We do have test data that unfortunately did not clear IETF timelines for us to publish. We'll certainly talk about these things later. I'm going to be skipping over many of these things because most of the people in the room are familiar with BGP fabrics. We see these in like RFC 7938, if I recall the RFC correctly. When we're starting to deal with things like AI fabrics, packet delay and loss are very impactful for the traffic. In many cases, the traffic is very bursty, has high throughput, and for a given burst of flow, very low entropy. And this means that congestion avoidance is critical. Dynamic load balancing, where you basically make a choice at a given node based on what you're seeing about traffic on your local interfaces, is extremely well deployed. This is basically taking our lovely ECMP conversations from earlier and talking about how does an implementation put its finger upon the scale to change the weight of load balancing. Random ECMP can't help us. Dynamic load balancing, when we detect congestion locally, helps quite a bit, but not enough. Global load balancing, which I think is a little bit of an overclaim. It's mostly reaching a step beyond the local device. Attempts to use information from a step or more further away to say that we're going to bias the local balancing choice in an attempt to avoid congestion that we're seeing remotely. Picking an easy example here, we have a folded 3-layer topology. And we see that we have a set of local next hops on L1, ABC, and remote next hops X2 and 3. And what we wanted to do is we want to keep track of, for this proposal, not only the next hop at the, towards L2 or L3 from the perspective of L1 at A, B, or C. We're trying to keep track of, how those things, fan out the next hop. This is one piece of what we need to deal with. We basically need to know what is our immediate reachability one layer out from what we're trying to bias. The second piece that's required for any of these proposals is how do we detect this sort of congestion when it's not local? So this requires a signaling mechanism. The mechanism that we're making use of for HPE Juniper and our authors at, I believe, H3C is the Broadcom mechanism. They do have a nice API and signaling layer that operates at L2 that does this. And effectively, it's going to give us a hint about what the congestion looks like that next hop. And we need a correlator for these sorts of things so that the line cards, when they receive this telemetry, can apply its finger to the scale and make a choice. The same thing is true here for folded 5 layers. We don't try to go more than that one extra next hop away. Our data is showing that just simply a little bit of extra hint gives us something that's good enough. There is discussion in other places about this additional data. The challenge becomes as you get further away from things that are running congestion as a biasing influence, timing becomes challenging. You're already having to buffer this at least one hop away. As you continue doing it, your telemetry itself may run too slow and just simply is not responsive for data center level balancing. What we do see is that we can do this recursively at each layer. The leaves can do it in the prior example. The spine can be done here as well. This holds up exactly the same. So in general, what we're looking at is that a device is only going to pay attention to its binding of its next hops for ECMP purposes, and for each next hop, the next hop for that route. And it's per route basis because this is BGP fabrics. We are tying these things to destinations. We use a congestion mechanism. Again, we're using the example of the Broadcom one. And we are not trying to solve the broader, can we do this in link state protocols? This is designed and tested for CLO-like topologies, and this should work for any regular topology. In terms of what we actually care about here for IDR and what we're standardizing, we're carrying via the next hop dependent characteristics, as John just talked about earlier, the next hop bindings, for a given next hop ID. The next hop dependent capability gives us that locally scoped per next hop binding that isn't going to flood the rest of the network with just this tiny bit of hint that we need to correlate this telemetry data and bias the traffic. We're carrying, in this case, the next hop ID, in the next hop ID as the router ID, BGP identifier, as our data. We've had discussions about maybe this could be something finer, like if you have parallel links between two devices. This encoding is very boring. The routing working group is taking a look at providing an IETF generalized mechanism similar to what Broadcom is doing. This is being done in the routing info draft, and it carries, again, something very similar, a biasing metric and enough information to allow for distribution between two systems. The results that we see in our actual deployed code is that with just dynamic load balancing, we're actually seeing very good help when we have local congestion. With global load balancing, we actually see excellent results when we're seeing AI level congestion. This is the kind of thing I was hoping to have full data for. Please pay attention to maybe IDR and possibly LinkedIn as we publish this data. In summary, AI ML impacts to your traffic and how this is happening for biasing things to avoid traffic drops is becoming incredibly important. This is a relatively lightweight mechanism for telemetry and for carrying one-step topology that significantly helps traffic flows in these circumstances. We have adopted this document. It is actually shipping into vendors. This makes John very happy because we get to take the draft that this is living on and provide the glue, move this forward. Our goal as a set of authors is we have our code point we're shipping this. We're looking to the working group to help us make the document quality better. And if there are extended use cases that fit within this framework, we are certainly happy to expand those for your use cases. And if it grows beyond something that fits into this document, well, let's ship this one and we'll move on to the next set. We have time for very brief questions. Seeing no questions, this is the last presentation for our session today. We'll see you on Friday. On time.